see you back again with sliding puzzle verification, a Python exercise from our old buddy Codewars. We are back home, folks. Always here, always grinded. Sliding puzzle verification. Okay. Given a board of n by n distributed with tiles labeled 0 to n squared minus 1 inclusive, a solved grid will have the tiles in order of label left to right, top to bottom. Return true if the board state is currently solved, and false if the board state is unsolved. The input's always going to be a square 2D list, and this one does not become clear until you look at the examples, like a lot of these Codewars exercises. Like, I don't know if you got what you're supposed to do from there, but I didn't when I initially looked at it. So let's look at the examples. A 2x2 solved grid is going to look like this, where we have this two-dimensional list. It's sequential, 0, 1, 2, 3. That is said to be solved, so that would return a true. A 2x2 unsolved grid has numbers that are not in sequential 1x1 order. And so whatever you got from this, the reality is that what's supposed to be done is check a two-dimensional list to see if all of the numbers are in sequential order, and really going from 0 to n squared minus 1, and n being the square dimensions of the list. So yeah, you just got to see if the you just got to see if the sequence stays in order and consecutive from 0 all the way up to n squared minus 1. So you're checking a two-dimensional list to see if all the numbers are sequential, and then that they end at the right value. So that's what you got to do. And realistically, you can get away with this one by simply determining if each number is one more than the one before it. You can simply do that, and that is what I'm going to do in my code. So let us and let me get into this mother. Enough talking, let's go. All right, got my header here. So I'm going to get a two-dimensional list, and I'm going to begin to loop through that list using nested looping, because I got to check every single. I'm sure there's a way to do it without checking every single one, but kind of the more spelled out normal way, I guess you could say, is going to be to check every single element. So what I'm going to do is I'm going to ensure that each element here, each integer, is one more than the last one, and that should represent a solved grid, because they're all in order, and they will carry through from 0 to the last value, which is n squared minus 1, as I keep repeating. I don't need to repeat myself anymore, right, folks? Right. So, strategy-wise, in dealing with a two-dimensional list, I'm gonna be checking the previous element to see if this element is one more than it. But there's a little dilemma. What if I'm on the first element of a new row? How do I check the previous? Because the previous is going to be in a different row. Kind of like this. Let's do this scenario. That is a 4 on the left. So, like, let's say I'm here on this second row, and this 4 is my J. I need to check the previous one, which is this 3 up here. And that 3 is on the previous row, so it's going to end up being I minus 1. And so I can't just check it doing my normal sequential stuff of like going to the previous J. That's not going to work, because J is going to equal 0 when I'm on this 4. If I go to the previous, it'll be j equals -1, and that ain't working. So long story short, I'm going to do a condition where I'm going to check it differently if j equals 0, and then for all other values of j, I'm going to do a different thing. So let's get into it. I know that was not a complete explanation, but maybe you will get it in the code. I don't like to do complete full walkthroughs all the time because of time considerations, but I don't need to explain myself. Nobody's watching this stuff anyway, right? All right. I'm being negative today, y'all. Gotta help me. Gotta get some PMA up in here, do some burpees. All right. So yeah, if j equals 0, I'm going to do a certain thing. I'm going to check if I equals 0. I know this is a little, it's like hella nesting, but it is what it is sometimes, folks. I'll explain this stuff once it's in because it's a little decent amount of typing. Yeah. More than 9 divisions. All right, that's a mouthful, ain't it? Yeah. So if j equals 0, which means if I'm at the beginning of a row, and if I is greater than 0, meaning that I am at least on the second row, because I don't need to do this for the first row. So if I'm at least on the second row, then I proceed. And what I'm going to do is I'm going to take the current element and I want to subtract it from the last element on the previous row to see if the difference is 1. And this is wrong, actually. The difference should be not -1, should be 1. So if the difference is not 1, meaning if this element is not 1 more than the one in the previous row, I have a failure because I'm not going sequentially. So I will return false here. All right, so that is one condition. And otherwise, I'm going to do kind of a normal test where if I'm within a row, I'm going to check the previous value to see if it is the previous value 1 less than the current value. So yeah, board ij minus board ij minus 1. And if that is not equal to 1, it means that I am not in sequence and I do not have a solved board, so to speak. I'll return false in that case. Not fail, I'll return false. Fail is different. Epic fails, yeah. And if I get through all of that and I haven't returned false yet, I'm going to return true, because that means that I've encountered no failure. They're all sequential, and I'm going to get to the end solved. Let's go, let's go, let's go. Pass and pass. Out freaking standing. There we go. So there is your solution to, I always have to look back to see what the hell it is. Yeah. Whoa. This is your solution to sliding puzzle verification, a Python exercise in Codewars, and that's it for me. That's all, folks. See y'all later.